I am from Agile Stacks. Agile Stacks has been acquired by EPAM, and here we are. I am still, as part of my legacy from Agile Stacks, I am maintaining open source, cool open source software called hubctl. And actually, you can find me on LinkedIn, on GitHub. You cannot find anymore on Twitter. It's X, currently called X. Yeah, it's X for me, so I won't respond on Twitter. I'm sorry for that. Yeah, actually not sorry. Yeah. Anyway, so last year ago, I was presenting the cloud engineering stuff and how to do the orchestration and so on. And this is what I was doing for all my time. My primary focus in EPAM at that time was actually how can we operationalize and productionalize the machine learning. We need to build a lot of software that will deliver infrastructure in automated way, and machine learning actually have got a lot of infrastructure, and this is why we need a lot of automation tools, a lot of integrations and so on, right? And roughly a year ago, I was contacted by VP of EPAM and asked like, hey Anton, how are you doing? Great, okay. Please stop doing whatever you do. We have elephant in the house called large language models. I need you just stop doing whatever you do. I need you to focus completely on that, right? And this is, then I just stopped. And then I completely went mad into the large language models. And immediately I realized that whatever I learned about machine learning for the last 10 years, I need to unlearn somehow and start to do things differently. So today I will speak a little bit oversimplified, and this is for a reason. Because when I do oversimplification, then I might not be able to be very correct from any angle. I'm sorry for that, right? So if I will speak truly politically correct and so on, you won't understand a word from me, right? So, and yeah. And since I'm an engineer, not a lawyer, then let me proceed with my talk. Yeah, actually, yeah. Do you understand what is this picture is about? Yeah. From like Anton did a marvelous talk previously, so I hope we understand. So basically, this is how our any kind of large language models actually work, right? So I will use this slide as the introduction, but basically, what we do, we have a large language model on the right side, and what we do, we need to ask a question to it. Right? The large language model is trained primarily on the task of completion, so it tries to guess what is the next word. Right? If I will say twinkle twinkle, it will say something. Right? If it will say something that I'm not expecting, I will decide that it's probably hallucinating. Oh, it's terrible. No, it's actually probably. What do we do in the software development when the software behaves in the unexpected way? We don't say it's hallucinate, we fix the bugs. Right? So the first statement that I would do, right, the majority of the hallucination that I have seen was actually the prompts that were inappropriately crafted. And when you change the model, you need to fine-tune the prompt, slightly update it. And that's okay, that's life. This is what typically, that's the same that I would do if I would change database. If yesterday I was running everything in database from Microsoft, and then I change it to another database, my select statements will behave slightly differently until I will fine-tune it, right? This is the same here. So what OpenAI did actually when they released the ChatGPT, their pretty much software on top of GPT model, is they made English is the most popular programming language. So everybody started to write programs in English, finally. So, and then the way as we write is the following. So we have a user, he has something that we call a prompt template. It's probably, he probably have a lot of templates. Depends on the model that they do, the task that he or she wants to accomplish. They will choose the appropriate template, put the whole text inside, and then go to the chat. And ask the question. Then the chat bot will, it's pretty much the software, the interface. There is a reason why we use chatbots as the primary interface. It's because inference is very slow. It's very consuming and very, how to say, compute consuming. And it's very slow. And because we don't want to exhaust user waiting until they will reach end of the completion, it may be in a few minutes, we try to push to them stream immediately whatever we got the result, we stream there. So just don't sleep, we are starting to answer, right? And we will do it for the next 2-3 minutes, don't worry. So apparently just chatbot is the most, the chat interface is just mostly user-friendly, if we can say like that, for the current generation of the models. I hope it will change soon, but right now we have what we have, right? So there are a couple of things that let me just show you just very quickly. Yeah, I will show you just when I was listening to the previous talk, I decided for some changes for the presentation because just because yeah, I think I needed to say something. Okay, can I move this here? Cool. Yeah, this is from the paper of the Michael Jordan. Very famous paper. It's a 1984. It's a first paper on the recurrent neural net. Pretty much, this is all what we need to know about ChatGPT or GPT models, right? It's just bigger. Like, okay, it's not just bigger. It's very complicated. It accumulates like half of century of the progress. But pretty much what we have. We have on the bottom the question. The prompt that comes into the model, it comes into the layers of the model. And here, what is interesting, there is it comes through the hidden layers and finds the most probable answer, right? How then what it does, it takes the answer and puts it back and reruns the loop to find the next answer, right? The thing is that the model has some window, like context window. This is the maximum size of the prompt that you can put, right? It's just limited. It's a hard limit, right? And then it has the memory, right? This is all information that it was previously trained. So it basically can combine both of them to calculate the most probable answer. Right, and this is why when it starts to answer to you, because it takes the previous answer and reruns it again until it will reach the end of tokens termination message, and then that will be it. This is why hallucinations does not exist, because it's technically it's not hallucination. It's the way as the model actually works, right? So. Unless I don't know something, yeah. But anyway, so next thing, it's about embeddings. This is how embeddings looks like. Another thing, this is important, right? Because we have just very small memory. Then what we try to do, we try to put the sequence of letters that statistically repeats again and again and again, we try to put it, give it a number. And then token is just a number of sequence of the letters that just has been repeated in the memory many times. That's it. It's that's it. And then basically we can put the tokens into some kind of tree, and then traversing the tree we can find the similar words, because they will have kind of similar numbers, and yeah, and this is actually how it works, right? So that's all what we need to know. And last but not least, just let me show you one more thing. Let me show you hallucinations. Right. This is another beautiful article. It's actually the music generator. This is where I started. It's the first time when I touched to the generative AI capabilities. I was attending the workshop in the Amazon to touch their models that were not publicly available, and then we tried to do some crazy stuff with it. At that time we've got just two use cases. One use case is language translation, and the second use case was actually music generation. Why language translation? Because if we do the embeddings, we calculate embeddings in English and in French, the similar words will have pretty much the similar numbers, but it will just be named differently. So this is how translation actually works. Easy. But since that, everything was changed. So I will try to play some music generated. I don't know if it will be possible. So it starts to play the music, and then we see that some syncopes, some notes become more intensive. The probability of some strange note becomes bigger. When longer music plays, the probability of strange notes becomes just bigger over the time. And this is what we call the hallucination. Why? Because it starts to play the music, it calculated something, then it puts back and say, just play something else. Oh. Yeah. Now it becomes something completely different than it was from the beginning, the music. Right? And this is what typically we call the hallucination. If I would do in the graphical way, right, this probably, like, if I would play this music, it starts very nicely, and then it becomes just, over the time, it becomes just rubbish, right? So, yeah, that's, this is, how to say, this is a graphical way of, or audio way for hallucination. This is what we call hallucinations. Technically, it's just the technical limitations of the model, but yeah, just important to remember. Anyway, just come back to the presentation. So if I ask the question, to the chatbot, then it should be able to give me a response. Let me check. So, and then basically, because it will give me a response, sometimes it may hallucinate, sometimes it's not, but actually, what are the problems? Problem number one, the knowledge cutoff time. So when I have a ChatGPT, if I ask what happened yesterday, then the model will not answer. It doesn't know. It has the knowledge cutoff time in when it started the training, pretty much, right? So this is the last knowledge. What happened after that, it doesn't know. It's just frozen in the time. So, and that's one problem. I can only ask. It has in memory everything what happened just before. Second, as I mentioned, the hallucinations, I don't really understand what this hallucination is from being an engineer, but we all agree this is the term that we use, it's a quality problem in my mind, right? And then the last but not least, the context window. This is quite important. You remember that there is only as much information I can fit into the model, and that's it, because it's just limited it's just limited by that, right? So that means that whatever I ask the question, I just need to compress all my question into this context window. Otherwise, I will not be able to put anything inside. And then I need to reserve some word because it will answer, add some stuff, and then push it again. So basically, the next completion will be just bigger. It still needs to squeeze into the context window, right? So if my model has, I don't know, like large model has, I don't know, 4 kilobytes of not 4 kilobytes, but 4,000 tokens, then it's not like my maximum question, my maximum prompt will be 4,000. No, because it will not be able to answer anything. It will overflow. So, but that's important. So then we start to, we try to crack these problems, and by cracking these problems, we first try to address how can we solve the problem when the model is frozen in the time, and just by the way as we do is actually how to say, we call it a RAG. It will pretty much look like that, but let me explain. So if I will ask the question something like, who won the Eurovision last year? The model won't answer. But if I will go to the Wikipedia, I will download the article who won the who won the Eurovision. I will put it inside of the prompt and give it an instruction. Look at the beginning of my prompt. Read it, and the answer on the question the answer on my question using information from the beginning of my prompt. Then it will give you an answer because it will just look there. This is pretty much RAG, retrieval augmented generator. Not something new, but this is how we. But this is probably the most popular design pattern that we have today. So the way as it works is the following: there is a document. There is that we kind of put into the batch job. That will cut it into the embeddings and then store it in the vector database. Just that's it. Then I need to do it in advance. It will take some time. There are many databases support vector format today by exactly these reasons, because database vendors want developers, when they will design the RAG, to use their database. Right. So then we have very simple bot. We do the same. So we ask the question. Then the chatbot, what it will do, it will go into the there is an abstraction called the memory, and at least it is called in the long chain. It's basically takes the chat history and adds it to the prompt, and then it will. And then what our software needs to do, will need to take the prompt from the appropriate prompt from the prompt library, go to the vector database, find the relevant documents, add also to the prompt, and then finally send it to the LLM, and then say, okay, just make some sense out of it, right? This is why this is how actually RAG application works, and that's it. We just, how to say, we just stuff as much as possible to the prompt. That's it. Clear? Questions? No? Okay. So this is how it will actually work. If I have a question, if I just imaginary question, then basically, do I have? Oh, should I incorrectly place it here. If I have a question, then the answer will be something like that. So basically, it will say something like, "Oh, actually, I went to the database. I found that the Apple Remote is actually used in iPhone, iPad, iPod, and like it will say." And then it will range by the probability, by the probability what is the most relevant, and then it will give the answer. Why it answer it like that? Very simple. When we store in the database, in the vector database, we actually store it in these embeddings, the numbers, and then we just look what are the closest numbers to this, and just give me 10 documents closest to this. Right? And then we usually do reranking. To be able to answer iPhone, iPad, iPod Touch in this order, we need to calculate the probability what user wants first, is asking first, right? This is how we call reranking. The problem with that is that we never give an exact answer. Whenever you need an exact answer, like you won't get it. Just last week we released a feature for our customer just for the technicians. It's they've got the chatbot. Like in the last time, in the previous time, pre-LLM time, they whenever they arrive to do the repair work in the some kind of store location or warehouse, they had to call to the dispatcher and ask the question like, okay, where is the parking lot? What is the phone number that I can call for the personnel and so on, right? What is the problem? Then what we've done, we just uploaded all this information into the database, and then we were hoping to make life easier. Just whenever they don't need to ask the question, they just say, okay, give me the phone number to this warehouse in Hollywood. Right? It will understand, okay, the Hollywood, California, then it's here is the phone number. Right? So, and it works pretty much good until we've got the question actually from the leadership. They ask it, okay, wow, it works. How many stores we have in the California? And then actually our system answered 10. They ask it, this is wrong. We have over 200 stores. Why is it happening? Why? It's very simple. Because we just took the question, California stores, went to the database, and because we have the settings like give us 10 documents, just it 10 documents that correspond to this question. We've got 10 documents. We calculated them and answered it 10. Easy, right? So all I say that all these RAG systems, they have limitations. They, on the one side, they are miraculously good, but they are miraculously stupid because there are limited of tasks that they can do. Yeah, right? And this actually obviously a wrong answer, but it's just what came from the database. That's it, right? By the similarity, right? Somewhere in the manual for iPhone or iPod was the word remote, right? So then, basically, what are the problems with that? First problem with the RAG is that these are the closed systems. So that means that it has only knowledge that I previously uploaded. So if everything happens after, I don't know until I will re-upload the data again, right? Then it's limited in the tasks. There are only scenarios that I can ask, and the other scenarios I just cannot ask. I need to give an instruction in the prompt to say like something like that, hey, actually this is an inappropriate answer, I can't help you. Otherwise, it will explain like, oops, it's 10, right? When it's had to explain something else because, yeah. And then actually sometimes it gives the non-relevant content, like I show it to you here. Why actually we limit it by 10 but not by 100 and so on, right? Because it doesn't know. It takes the select from the database. It takes what is the most relevant document. Like give me, and then it will give whatever the filter you will give. Like give me 10, it will give you 10. Give me 100, it will give you 100. The only problem is that when user will read the documents, on the top, there will be quite good documents, quite relevant, if you do re-ranking. And then closer to the bottom, it will be completely rubbish, just nonsense. Because yeah, it's this is how similarity search works. It's not exact keyword search. It's a little bit, in this case, it's a little bit fuzzy. So you need to put the limit and say, okay, don't take more than 10 documents. And that's because you just expect that 10 documents will be relevant and will answer most likely the question of the user. Okay? So, but if you give it a wrong filter, you probably will have some wrong information, right? And especially if you do another task summarization, that can become interesting. What the summarization is, when you give it the whole documents that you fetched from the database, half of them are relevant, half of them just by accident appeared, and then you put it in the model and ask, read all these documents and give me what you, and summarize it in 3 sentences. What are these documents is about? Then it will give you, like in the beginning, it will start to read, it will put some sentences, some relevant information, some complete rubbish. And people will say again, oh, this is hallucination. No, it's actually, yeah, it's a bug. Anyway. Yeah. So basically, when you need RAG, you need to create a helpful assistant. Q&A, question and answer, summarize, criticize, by the way, it's a very good use case. What do I mean criticize? This is my favorite case because I am very bad in writing emails. I can, before I send email, I can ask, can you please proofread for me, right? And then, yeah, it will say something like, okay, yeah. So criticize is super important. Then, but don't ask it something like, please calculate something and so on, right? It will give you wrong results. Just don't ask it to reason too much. Because we have another pattern, react, reason and act, right? We need to, how it works is the following. It takes the prompt, then it tries to split it into something that we call a thought. A thought is the part of the prompt that makes sense to perform an action. It sometimes does well, sometimes does not. The problem with the sentence, because human language is very bad language from that perspective, it has sentences inside of the sentences, and it's very rigid. It's if you wanna. You really need to formulate your question in a very, very, very specific way to get something useful, to get it broken down into the thoughts in a very nice way, right? So, but if you do, then what it will do, it will create, it will break your question into the sequence of thoughts. It will create a plan out of thoughts and start execute one by one in the loop. And then what it will do, it will need something that we call tool. At least it's called in LangChain tool. The tool is a part of the software that can take the prompt, what is written in the prompt, and then execute the task. Go to the internet, scrap the information from the internet, go to real database, call API, or start the process, or something else, right? It's from that perspective, we started to call this software as the agent. Yeah, this piece of software doesn't have agency, but we somehow call it an agent. But this is already something. So we ask model to reason, break question into the sequence of thoughts, plan what will be first, second, and so on, and start to execute. The thing is that we don't always know the answer. And that's the key essence of my today's talk, because the biggest problem I see today with the old systems, we only, like majority of the users only have seen the discrete systems that are deterministic, right? It's 1 or 0. It's working or not. But here we don't always know the result, right? The thoughts might be a little bit fuzzy, a little bit unconcrete, and so on. And there can be, and then tool can be applied. For example, what if my thought is asking like, go to the real database? because there is a question: how many stores in California, right? Then the LLM will say, oh, this actually you should execute the database query instead of vector search. Right? It will help to formulate the database query with the parameters, and then tool will execute it, right? But I may mistype California, then I can get strange results, right? And so on. So, and then basically, especially if you type something like Hollywood, I cannot write it properly. Then, yeah, the LLM may guess it's something else. And then I can get different results. So that means that my system will work, but it will work it most likely will give the result that I need, but sometimes not, right? And it doesn't mean that it's buggy. It just behaves more like a human, because our human, like, we never deliver software like as it has been asked. It's almost like that, but it has some deviations always, right? At least in my practice, right? Anyway, what are the, if I would ask from the same question, it would give me this answer. Basically, it will break down the question into the sequence of thoughts, and then it will try to extract some information from that and then to formulate the answer, right? This is what we call chain of thoughts, by the way, yeah. And yeah, that's pretty much how it works, right? So, and why do we need this? Because we can do really cool stuff with this. Because we can write the software that is not frozen in time because of the database that has been updated somewhere in the background process. It can go to if it cannot find the information, it can go to the internet and scrap some information, for example, right? Or do some other stuff. You can write English to SQL software and so on, right? You can you can put into prompt like English to SQL, and then you ask just paint the picture, and then in theory, you don't need the data analyst anymore, in theory, right? But yeah, so basically, yeah, this is what React are doing. Oh yeah, I need to go faster. So yeah, and then we go to the multi-actor applications, right? So yeah. There are many alternatives. So first thing to remember, right? This is the pattern that I want you to show. Basically, what about because we have this React and reason and act applications, we can give we can put them these multiple applications together into one chat room. Right, we can give to this reason and act application, we can give it something that is called system prompt, something like the message that it must do. And then you can say, for example, you are the creative designer, you create wonderful ideas, and so on. Right, and it will just, and then we adjust temperature to go as wild as possible. Then we take another one, you say, you are professional database engineer, you take the creative idea and you create a SQL statement out of it. That will make sense. And by the way, our database looks like this. Right, then you go next and say, you are a developer, when you see the SQL statement, you know how to write the code for that. And then you come to the next agent, you say, when you see the code, just run it, and so on, right? And this is, and then you have critic who will just execute the code, correspond the result. It will say the result is good or not. If not, what is wrong? And then it will come back to the first agent, who is creative designer, who generates the idea that got the feedback, and then it will generate new idea. And with a few iterations, there is a hope that they will solve the problem. Right? This is the whole idea of this conversational agents, and in my mind, this is something that will be our future, basically, right? So there is only one problem with that. Actually, yeah, the first problem, the non-deterministic result. Sometimes if you will give too complex problem, they cannot crack. They will spend some iterations of, and then they will give up. And because the problem is too complex for them, you need maybe to create better agent or make a simple or ask a simple problem, right? The second thing is that because it will do not one stuff, they will run many times. They can burn budget very fast, because they will generate many inferences for the LLM. So this is where it must be you must use quite careful, right? And then it's still closed systems actually, right? Virtually closed. They can go outside, but still they can only do what is inside of this chat is about. And then, by the way, you're responsible to form the chat. You're responsible to identify what are the agents, what are the pieces of software you need to join together. Right? Let me just very quickly show you. I already been hinted that there is only 10 minutes. But yeah, so okay. Can I do screen mirroring? It's black screen. Not black. What's happening? Okay. Oh, okay. Now it's good. Okay. So, okay. So if I go to my LLM proxy, I will explain. If you have a question, why do you need LLM proxy? I can give. After the talk, I will explain you in someone, right? It deserves its own talk. But if I will ask a question, what date is today? So the answer is actually no idea, because it's not in the memory, right? So I can change the model. I can ask GPT-4. I can go to the Mistral, and I can ask. Oh, sorry. So I asked the question, what is the date of today? And the model cannot answer, because it doesn't know. It's not in the memory, right? So because what is your latest memory? Oh, it's Mistral. It will be slower because it's running on my computer locally. It will be slower, yeah. Okay, yeah, it started to write some rubbish, okay. Not interesting, okay. GPT, please help me. The cheaper GPT, please. Yeah. What is your latest memory? Let's see what, yeah. Okay, they put some guardrails anyway. So basically, there are some models that will give you exact date, what is the latest memory. But let's ask the question to the agents. So let me give the problem. What date is today? Good problem to have, right? To have the problem. And let me run this code, and I will explain what is happening here. So I will create a very primitive chat of two agents. One is called an assistant agent. I call it a coder. I will explain why the coder is, right? And then I will have the user proxy agent, which is myself, right? Whenever I run the program, can you see it? Should I enlarge it? Let me try. Okay, better? Yeah, I feel like in the old days. Okay, what date is today, right? I run it in the corresponding mode. Then what it says? Oh, by the way, yes, you can know what's the date. Just run this Python. You will know what's the date. Then I can say, okay, I'm okay. Just run the Python. I'm okay with that. And then I'll say, oh, that's today. Right? That's the thing that it works. So basically, if I don't have any questions to it, I can always say terminate, and that will be done. Why this is so? Why it gave me the question in Python? Because if I go inside, I will look at something that is called system message. This is the base level instruction that is given to this agent before it will add my question, right? This is like, it takes the prompt, it takes this is higher level prompt, and then we'll add my question to the bottom, to this. And then it says, you solve the task, blah, 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 and using Python or shell script. And that's it. I can change it to Java, then it will respond in Java for me, right? But that's the whole idea. Then, by having this, because it starts to write the code, I can ask the different question. Okay, so download the first article from HTTP, the club.lv.
You misspelled from.
Sorry?
From.
Oh, from, yes. Yeah, that could be a problem because, yeah. Thank you. Yes, I always misspell when a whole bunch of people are watching on my screen, yes. Yeah. And the second thing what happens, somebody from my family is calling to me and asking some stupid question like about computer. Always happening. Anyway, so I asked this question to the same chat group, and then let's see. So the coder will say, yeah, you can, by the way, this is how you can download, yeah, you can run shell to download the article, okay. I can say, okay, let's do it. And then it downloaded something, okay, it's not interesting, okay. Download, okay. Go to then download first article and who are the speakers for today. Let's change the prompt. That's gonna be interesting. Yeah. The thing is that, how to say, I practiced this question several times, but it always gives slightly different answer because it's probabilistic. This time it decided that shell script will be more efficient to my question. Next time it will print Python. But let's see. I'm trying to trick it not to answer my question like in shell. I cannot browse this. Okay, I say okay, not a problem. Okay. Let me give it a question that I specially prepared. Right. So download the web page from devclub.com and to get the first article. And who are the speakers? Let's little bit simplify this question. Right. Again, the way as we formulate it, because it will break it into the chain of thoughts, it will take the first thought and try to generate Python or Java or just reject. Right. So it will say, oh yes, by the way, this is how you can do it, right? Just Python. Yes, use the request, beautiful soup, run the stuff, and then do it. Just yeah. And then I will say, and then I say, oh, I'm running the code. And I have this request not found, like this problem, right? This is the feedback. It says, oh yeah, just run pip install. And I say, okay. It thinks something. And by the way, there is in Autogen there is a safety mechanism because it's running Docker by default. So it does it inside of the Docker. So it would not install some rubbish in my computer, I hope, right? But yeah, now I installed the requests, then it will say, just repeat this comment again now. Let's say, run it in again, it will say, oh, beautiful soup is not installed. Yes, because we are running in Docker. Yes, we didn't install this. Yeah. By the way, you can put bigger container with all this beautiful soup and so on, and then hope that the next package, you will have next package for the next user prompt and so on. Right, but and then it will pretty much do the stuff, download the beautiful soup for me, and then rerun the prompt, and then it will start to do something. It downloaded the page, started to bring it, and what are the answer? I think it was not able to answer. Okay. The way as it works, like, let me show you, like, what it does. It generated these web scrapers. This is the code that it generated and run, right? So, and then it's just, it tries to trick me. It just plays the speakers, and then it tries to find a class called speaker, right? Okay. So, let me just do it. Okay, it doesn't really know. Okay. Anyway, this is this is how it works. Okay, but what I can do, I can make it less interactive. Let's see if with the next iteration it will solve the problem. What I will do, I will go into my assistant agent, usage 1, and then I will say, now go wild and go I will not interact with you, just never. Right? There are some instructions I can say, like I can interact sometimes, but okay, just never. Do the 10 repetitions, I don't care, right? And then just try to solve the task in 10 iterations. Let's see what will happen. Last time it solved the problem by itself. Let's see. Again, it says, like, install the requests because it's Docker. It doesn't have these requests. The default image that I'm using, it will download it again. And then it will, again, the beautiful soup is not there. Then it might get generated slightly different now. No, it's actually the same code that it generated. It's cached. Not interesting, okay. What I can do, I can change the temperature. I can put it 0.7 or 0.8. This is the level of creativity that I can apply to it. Right? Oh, by the way, it started, Yeah, this is, people, this is most important from this talk. This is the way as non-deterministic systems actually work. They sometimes solve the problem, sometimes don't. Similar as the human. You give it a task. Sometimes the plumber makes the job done. Sometimes the plumber leaves your kitchen in the nasty way and says, sorry. Right? Anyway, so there is one more thing that I think I won't have so much time, but let me show you one more thing. So this is the new feature of Autogen. What if I will use Autogen to generate the code of Autogen to run it? In this case, I don't need a fixed chat. I don't need to say like I need this agent or that agent. I don't know. I can give him a problem. It's a problem. Just let's put it like that. Like, or let me change it to this problem, by the way. Yes, the same problem. I ask, and then basically I will run the code, and then basically it will do the. And then basically it will do the trick. So I will use this time I will use GPT-4 model, more expensive than I was using to execute the code, to generate very simple code. But this model is like the code that it will generate, it will be more complex, because the way is just to scribe with the beautiful soup the website is quite a simple problem, and GPT 3.5 will be good enough. But to write the code that will generate the chat of the agents and identify what agents are needed, you need more capable model, more expensive, the inference will be bigger. So it identified that it will need a web scraper agent. It identified it need content analyst. Wow, interesting. Did I put? Oh yes, I put it temperature 0.7. I made it a little bit more wild, right? So and then it's still thinking. It's still thinking. It will identify the agent, and then I will be able to run the code with the. Then I will be able to generate the group chat with the more agents inside, and then they will crack the problem or not, right? Yeah, I guess I don't have so much time, but let's wait for this. I think I won't have much time to run this code, and especially as I've got the last minute thing that it was complaining that it's not able to run this agent by some reasons. And yeah, I won't run it, but I will just show what's happening. So basically, it will generate for me the files, okay, and gives an error sometimes. 404, wow. Wow, this is unexpected. Okay, interesting. Okay, but I will show you exactly, approximately what it will run. It basically identifies the agent. It will give this a system message, who this agent are and what the task for this agent will be. Then it will group it into the chat, and then it will ask to iterate them to solve the problem, right? There is a different abstraction for that called group chat, and then it will work. Here is one caveat that I want you to point. What to do and not get bankrupted, because it really generates, even for simple problem, it generates a lot of inferences. Even simple question you ask, like if you have database and you ask how many unique users I have for the last night in my website, it will generate, I don't know, maybe 10, 20 inferences until it will figure out what is the SQL statement it needs to have, right? It will be still cheaper if you will hire a special human to do this operation, right? But it will be costly still, right? So, and then, by the way, you can ask like to point this plot a chart. It will plot the chart, but basically it will be still cheaper if human would do this. But this task is kind of, it will be still expensive. It will be maybe $5 of your wallet, right? This is why you need open source models. With the open source models, they are different. You need to figure out what exactly prompt will correspond to this model. It will be different. It might be different for the different model, right? And usually, as I mentioned, like there is no like the most common question I answer, like what is the best model? It's the same question like what is the best programming language? Right? We all know the worst programming language. We don't know what is the best programming language, right? So and then the same with the model. There is like somebody say, oh, this model is bad. The way is they test. They take the prompt. They ask GPT, ChatGPT with this prompt. Then they ask Mistral, and it gives the different result. And they say, oh, this model gets a different result. It's bad. No, fine tune the prompt. Right? So when you figure out the prompts, then you can mix and match these models, the open source models. You can leave the really hard tasks, final tasks to execute to expensive models, and then you leave cheaper tasks to generate some code, to run the code, and so on in this model, right? It's unfortunately I don't have time to run the model and just to ask to solve the same problem with the brainfuck language, but maybe like next time. This is why you need actually one thing. You need LLM proxy. This I use Light LLM for that. Basically, what I have here some some OpenAI models, and some open source models hosted locally. Why? Because, and then I have, why? Because before I give a task to the agent, and every agent can operate with a different model, as you understood. I can mix and match the models, and my application will still use this OpenAI API. It will think that it talks to the OpenAI, but in fact it talks to the different models, right? This is the way I can change the models, I can update it, I can do mix and match different pieces, and without actually rewriting the application. This is why you need LLM proxy for that, right? Okay, then I guess this is it for me. Yeah, questions?